Hi everyone, welcome to this class. Today we are going to look into the topic train related problems of the chapter speed, time and distance. Today I will tell you three types of problems that you need to know. Anything apart from this is not necessary for any exam. These are the basic problems you should definitely know. So type 1 is time and distance formula, type 2 is train and object, and type 3 is relative velocity. In this video, we'll cover these two types of problems, and the next video will discuss about relative velocity. Before proceeding, we need to know the conversion method of units. That is conversion of kilometer per hour to meter per second or meter per second to kilometer per hour. We need to know these conversions. When you need to convert kilometer per hour from meter per second, then you have to multiply the speed by 5 by 18. Multiply the speed by 5 by 18. And if it is meter per second to kilometer per hour, then you have to multiply by 18 by 5. 5 by 18 for kilometer per hour to meter per second and 18 by 5 for meter per second to kilometer per hour. Multiply the speed with these fractions 5 by 18 and 18 by 5. So people get lot confused by this 5 by 18 or 18 by 5. See, kilometer is bigger unit than meter. So when you convert kilometer per hour to meter per second, multiply by 5 by 18, which is a smaller fraction than 18 by 5. Smaller number will be in the numerator, 5 by 18, and meter per second to kilometer per hour, that means smaller unit to bigger unit, so bigger number will be in the numerator, 18 by 5. Simple to remember, right? Suppose we need to convert 54 kilometer per hour into meter per second. So we have to multiply 54 multiplied by 5 by 18 meter per second. That is 5 3 is 15 meter per second. 15 meter per second. If we need to convert meter per second to kilometer per hour, suppose 25 meter per second, 25 meter per second, we have to convert it into kilometer per hour. So 25 multiplied by 18 by 5, that means 5 5s are 25, 5 8s are 18 5s are 90 kilometer per hour. 90 kilometer per hour. The type 1 of train related problem is time distance formula. So the formula that we have to remember here is speed equal to distance by time. By using this formula, we can find speed of the train or any other vehicle. If they ask for distance, then we have to multiply speed into time, speed and time. The product of speed and time is equal to distance. If they ask for time, then we have to if they ask for time, then we have to divide distance by speed. We have to divide the distance by speed. Time equal to distance by speed. If they ask for distance, then we have to multiply speed with time. So these are the basic formulas. These are the basic formulas we have to use in this type of question. This is the most common question you have to face in any exam. Let us solve a basic problem to understand the formula better. Here is a question. A train covers 14 km in 12 minutes. what is the speed of the train? We express the speed of a train in kilometer per hour, but here the time is given in minutes. So we can convert this minute into hour or seconds or in second. So time is 12 minutes, that is 12 by 60 hours. So that is 1 by 5 hours, and the distance is 14 kilometer. So speed equal to distance by time. Distance is 14 divided by 1 by 5. So 14 multiply 5 by 1, that will give 70 kilometer per hour. So now you would have understand the formula much better. Here in this question the time is given and distance is given, and they ask for the speed. So speed equal to distance by time. In certain questions they will give the distance and speed and ask for time. When you read the question, always remember to write the given data so that you don't make a mistake. The second type of train related problem is train and object. The train and object problems are of two types. When a train is crossing pole or a tree or a man, and other type is when a train is crossing a bridge or a platform or a tunnel. Let's get started with pole, man or tree. When a train is crossing a pole, suppose this is a train crossing a pole. When the front part of the train start moving here, the train started crossing the pole, and when the back of the train crossed the pole, then we can say the train completely crossed the pole. So the distance covered by the train for crossing the pole is its own length. The length of the train will be the distance covered by the train when it crosses a pole or a man or a tree. So the distance traveled by the train to cover the pole, to cross the pole, will be the length of the train. Distance will be the length of the train, and then we can use that formula as speed equal to distance by time according to the problem. Let's see what happens when a train crosses a platform or a bridge. Suppose this is a platform and a train is crossing that platform. When the front end of the train starts from here, it will start crossing the platform, and when the train comes here, that means the back of the train comes here, then we can say the train completely crossed the bridge. So what distance covered by the train? The distance covered by the train is the length of the train plus length of the platform, The train covered the distance, the sum of the length of the train and the length of the platform. So the distance will be length of the train plus length of the platform, and then we can use this formula speed equal to distance by time according to the problem. Let us solve few problems to understand the concepts much better. Here is a question: find the time taken by a train 150 meter long, running at 60 km per hour in crossing a man standing on the platform. When the train is crossing a man, suppose this is train, and if the train is crossing this man, when the train covers the man, when the back of the train comes, when the back of the train comes here, when the back of the train comes here, that means the distance covered by the train is the length of the train. The distance is 150 meter. As I said earlier, always write the given data. Distance equal to 150 meter, speed equal to 60 km per hour. But see here, it is in distance in meter and the speed is in kilometer per hour. So we have to convert the kilometer per hour into meter per second. To convert kilometer per hour to meter per second, we have to multiply by 5 by 18 meter per second. So 6 3s are 18, 6 10s are 50 by 3 meter per second. Speed is 50 by 3 meter per second. So the time taken by the train will be time equal to distance by speed. 150 by 50 upon 3, that is 150 multiply 3 by 50. So 9 seconds. 9 seconds. The train will take 9 seconds to cross the man standing on the platform. This will be the answer. In the previous questions, we dealt with a single object, that is a pole or a bridge. In the next question, they are together. It's a bit tricky, but if you understand the concept, it is very easy. The question is, a train moves past a man and a bridge of 260 meter long in 8 seconds and 10 seconds respectively. That means train crosses the man in 8 seconds and the train crosses a bridge of length 260 meter in 10 seconds. They ask for the speed of the train. What is the speed of the train? So let the speed be of the train is s. So we know to cross a man, the train requires to cover the distance of its own length. Let the length of the train be L. So time, we know S equal to distance by time. So S equal to distance is L, time is given 8 seconds. So 8S equal to L is an equation. Again, when a train crosses a bridge, the distance covered by the train is the sum of length of the train plus length of the bridge. So distance, speed equal to distance by time. So S equal to distance is 260 plus L by time 10 seconds. So 10S equal to 260 plus L. Now from equation 1 we know L equal to 8S. put this value from equation 1. Bring it to the left side. 10s minus 8s equal to 260. So 2s equal to 260. So speed of the train is 260 by 2, that is 130. So it is 130 meter per second. 130 meter per second. Now you would have understand the formula much better. In the next video, we'll discuss about the problems on relative speed of train problems. Thanks for watching.